So oftentimes students are learning about the sine, cosine, and tangent curve, and they have a lot of difficulty trying to understand how to come up with this curve. So what I want to do in this video is I want to show you using the unit circle and how we're actually just plotting the graph through the different quadrants. So I'm going to start with the sine curve here. Let's go with sine graph. But before I do the sine graph, what I'm going to do here is I'm going to do a unit circle. And we have to remember the unit circle. In the unit circle, we have, where is that? Get something much straighter. Okay, so in the unit circle, we have this. We are going to start, this is 0 here. This is 90 or pi over 2. This is 180 or pi. And then this is 270 degrees or is degrees here and degrees here, or 3 pi over 2. And here we have 2 pi or 360 degrees. So what we have to remember when we're drawing the sine graph is that when we are in the unit circle, we have our coordinates as cosine, sine. So here, where we have, remember our unit circle, we have 1 here, 1 here, -1 here, and -1 here. So let's just go ahead and just draw this circle. Okay, so here we have x is 1, y is 0. Here we have 0, 1. Here we have -1, 0. And then here we have 0, -1. So what I want you to remember here is that the x coordinate represents cosine and the y coordinate represents sine. So if we want to focus on the sine graph, here's what we're going to do. We're going to draw our axis here, and we're just going to go from the first quadrant and we're just going to go around. So let's go ahead and have 0, and then we have pi over 2. We have pi, then we have 3 pi over 2, and then we have 2 pi. So here our sine at the beginning is 0, so we're going to start over here at 0. And then at pi over 2 it's 1, so you can see that here. Then we get to pi, it is 0, we come back here. At 3 pi over 2 it is -1, so we come back here, and at 2 pi we get back to 0. So this is what the graph is going to look like. Go down here, and then we end over here. So this is simply what our sine graph is going to look like. Now, what if we had to do a cosine graph? This is where, and if you understand this concept that the sine, cosine, and tangent graph are actually derived by just going through the 4 quadrants in the unit circle, this makes it a lot easier to understand. So now let's go ahead and try to draw a cosine graph. Let's erase this here. And we're going to draw our cosine graph. Okay, so with our cosine graph, this is cosine graph. Let's go ahead and draw our axis here. Well, here we're going to pay attention to cosine, which is the x value at each of these points on the unit circle. So we're going to start 0. We have pi over 2. We have pi. We have 3 pi over 2. And then we have 2 pi. So at the beginning here, we have 1. So we're going to start here at 1. Then we go to 0. We go down here to 0. Then here to -1, which is right here. Then we go to 0 again. And then we go to 1 right here. So now we're going to try to follow the path. So we start here, go to 0, to -1, to 0, and then, so that's what our cosine graph tends to look like. Now, there shouldn't be much of a hassle trying to understand this. We can see here that as we go through this quadrant, you'll see that we are following the path of, we're following the path of this unit circle, and we're also paying attention to something really important, the value of this trig ratio at each of the quadrants. You can see here that we start here where every value, I'm going to introduce you to this, is a cast, C-A-S-T, or some will say all students take calculus if you're going from quadrant 1 through quadrant 4. And here, this simply means that all trig ratios are positive in the first quadrant. In the second quadrant, what you're going to see here is only sine and its derived ratios are going to be positive. So here we're talking about sine and cosecant. And in the third quadrant, we have tan and its derived ratios. So we have tan and cotangent. And in the fourth quadrant, we have cosine and secant. These are the only ratios that are positive in this quadrant. And we can see that here, if we were to draw a line right here, let's try to draw a line right here, right here, right here, and then right here. What you will see here is that from this is 0 here, this is quadrant number 1, this is quadrant number 2, this is quadrant number 3, and this is quadrant number 4. So you can see here for cosine, quadrant number 1 is positive, quadrant number 2 is negative, quadrant number 3 is negative, and quadrant number 4 is positive. So that's pretty much how the unit, understanding the unit circle, makes all of these very simple to understand. Now, we're going to go to tangent, and that's where this application becomes so much more relevant. So I'm going to go ahead and erase the screen. Okay, so we're going to talk about the tangent graph, or the tan graph. So let's go ahead and we're going to draw. Now, what we know about tan is that the period of tan is pi. So what we're going to see here, I'm going to just go ahead and draw this. This is pi over 2, and then pi. So what it simply means is that the graph behaves the same every pi units. Now we are going to look at something very unique here. And what we're going to see here is that we start off positive, and then we go to negative, then we start positive, and we go to negative. That is really what we're trying to see with this period. Now, a few important things, but I'm going to draw this all the way to 2 pi, just so that I can show you something. So this is 3 pi over 2, and then this is 2 pi. So remember that tan is your sine of the angle divided by the cosine of that angle. So we have to remember that anytime in any of these points where sine is 1 and cosine is 0, we're going to have an asymptote. An asymptote means that the function is undefined at that point. So what that tells me here, if I look at this right here, 90 degrees, so this is cosine. Remember, this is cosine and this is sine. This is 1 over 0. Sine over cosine is going to be 1 over 0, which is undefined. So we're going to have an asymptote at pi over 2. We're going to have another asymptote right here at 3 pi over 2. So now let's go ahead and just walk through the graph. So here, tan is 0. So at 0, we're going to start from 0 and we're going to stay on the positive side of the y. We're going to stay above in the positive y-axis until we get to the asymptote. So this is what we're going to start here, and then we're going to go towards the asymptote. Now we get to the asymptote, and here tan is negative. So that means that we're going to go from the asymptote on the negative side until we get to right here where tan is 0. So we're going to start from here, negative part of the asymptote here, and then we go all the way to 0. Okay, so now we have covered the first two quadrants. Now let's go to the third quadrant. Here, tan is positive, and we're going to go from 0 until we get to another asymptote. So we go from 0 until we get to the asymptote. And then here, tan is negative, so we go from the asymptote on the negative side, on the negative y, until we get to 0 again. So you can see how important this unit circle can be, or is rather, when you are trying to draw the graph of trigonometric ratios. And so I just wanted to make sure that you understood the relationship between the unit circle and your ability to comfortably and confidently draw the graph of trigonometric ratios.